Hello, everyone.
Good morning. I mean,
Hello.
Good morning.
Good
Good
morning, sir.
afternoon, sir.
good
Good
morning.
morning.
Good
Good
evening.
afternoon.
Morning.
Good
Hello,
morning,
good
sir.
Good afternoon, sir.
Good afternoon.
Uh, sir, I'm sorry to disturb, but I don't have any access to a chat box.
All right, don't worry about it. As soon as everybody will have it together, I guess.
Okay, thank you.
Okay, let's just give another minute for everyone to join in. In the meanwhile, can I request everyone to make sure that you mention your names correctly on your profiles? I can see some iPads. I can see some no names at all. We request everyone to just make sure that you put your name so that if there's an opportunity for us to engage, we would love to have your names there so that we can call out and we can request you to join us in solving some of the sums.
So, actually, my parents are not there at home, so I don't know how to change my name, so I won't be able to.
If you
All
go
right,
to participants at the bottom, you should be able to see your name and change it. It should say rename.
what's do you know what's showing on your name? Is it at this point? I can't see who this is actually.
Mute off. Almost off.
It's iPad QWE, something like that going on.
Okay, let me rename it for you. What's your name?
Ashvi, AASHVI.
AASHVI. There you go.
Thank you.
Welcome. All right. I think we have quite a few of us here. We will, I think we are about 2 minutes over the time. So I think it's about time for us to start. First of all, I would like to thank everyone for having joined the session today. I'm Avinash Shetty from Live Math Competitions and Leagues. Today's session is for the Grandmaster category. And we have participants from all around the world. This year, we already have registrations from more than 57 countries up until now. And we are the last leg of the registrations. So hopefully, we do hope that we have we beat last year's 59 countries, and see if we can add some more countries to the list. Having said that, today's session will be led by none other than Mr. Daniel Timms. Daniel Timms is a renowned mental math expert and coach. He is just not into training, but he also participates in competitions worldwide, and he's got quite a few records to his name when it comes to mental calculation, including mental calendar dates related records, and that is he's well known for. Apart from that, obviously, he also trains and coaches high performance coaching for mental calculation for top performing mental calculators in the world. So it's a huge privilege to have him here with us today. And he's been with us since the last couple of years, and he's been nice enough to come and impart his knowledge to all our Grandmaster participants since the last couple of years. And you are the lucky few who are again benefiting from his presence today. With that said, before we start, I would like to just make sure that we follow some of the rules of how we are going to be conducting this session. Just make sure that you if you have a question, you may drop your questions in the chat box. And as much as we can, we will try to answer some of those questions. what we'll also be doing is in between when we are solving some of the sums, some of the techniques are being shown by Daniel. He may want to engage with some of you, and we may want to solve it together. So at that time, we may ask you to unmute yourself. So please make sure that there is no disturbance around you while you do that. It would be great to have for you all to have a pen and paper handy so that you all can write down some of the techniques that are going to be shown today. The recording of this session will also be available later on, so you would get it, but it's always best that you practice while it is being taught during this session. So just try to make the most of this time that you have with us over here. Again, you may have a lot of questions regarding the Mental Math World Cup, about the mock test that is going to be coming up between the 25th to the 28th, or the round one that is going to be happening between the 1st to the 5th of August. All those questions that you may have, please drop us an email or drop us a WhatsApp for that. Our email is contact@livemcl.com, and our number is +91 8291 0272 27238. So you can just drop us all your questions there. We'll be very happy to answer those questions for you. All right. So any competition related queries, just drop the message to us. And if you are finding it difficult to hear us or see us, it's best that you may put your cameras off in that case. So in that case, you'll be able to hear us better. All right. I think these are the rules of engagement today. So I hope everybody is fine with that. Can I have a thumbs up from all of you? That's great. Okay. So Daniel, thank you for your presence today, and I would like to hand it over to you now for taking the session forward from here.
Sure. Thank you very much for the introduction, Abhinav. As Abhinav said, I'm Daniel. I have been working in mental math since 2012, when I competed for the UK in my first competition. And at that time, there weren't many resources available for people who wanted to study mental math. So it's really good that Live MCL and League has produced, for example, this workshop to give you the opportunities to learn more mental math skills that can help you in competitions like the Mental Math World Cup. I'll start with a little introduction to me. So this is the workshop that we're having today, where I'm going to show you important methods that you can use in the Mental Math World Cup and beyond. I am from the UK. I'm currently in Oxford at this moment, but I travel around quite a bit throughout the year. I studied mathematics at university and then became a software developer. And in 2016, I quit my job, and then usually I'm in a different country every month since then. So recently I was in Vietnam and the Philippines, Bulgaria, these countries. Since 2012, I've been competing in or being involved in some way in a lot of the international competitions, and the Mental Math World Cup is why we're here today, preparing for that. I've been a mental math coach at events, including what I'm doing right now. And some of you may be aware of the World Mental Calculation website, which is the black and white website with many resources and methods. I'll show you some of those today, but this is some of the work that I've been doing with mental maths.
Daniel, just give me a moment. Just let me mute all participants for one moment, please.
Sure, yeah. Okay, thank you for that. So what are we going to do in this workshop? We're going to have a look at multiplication, percentages, and squares. These are all related to multiplication. We're also going to look at square roots, which is like squaring a number, but it's the opposite. We're also going to have a look at division by 1-digit and 2-digit numbers, and we can see some more advanced techniques for division. All mental math requires an ability to manipulate numbers in your head if you want to do it quickly. And the most basic of that is doing addition and subtraction. Most of these methods require you to do some addition or subtraction as part of the method. For example, for multiplication or for square roots. So I'll give you some exercises that can improve that to make you better at all types of mental math. We'll also look at cube roots, highest common factor, lowest common factor, prime factors, and a couple other things. And there'll also be the opportunity at the end for any other questions and answers. As Avinav said, if you have questions about the competition itself, it's better to do that by email or WhatsApp to the team there. The question and answers are mainly for questions about the mental math methods. Before we begin, I'd like to know who's on this call. So could I invite everyone to send a message if you can in the chats with the country that you're in. What country are you in? So we have India, India, a lot of people from India, from the UAE. UAE, which other countries do we have here? We have Romania, someone for the UAE and India. Cool, really good. From Bangladesh, from Qatar, from the Seychelles Islands, very cool. From Malaysia, I was in Malaysia actually in January. I was in Kuala Lumpur, Bahrain, the Philippines. I was in the Philippines as well in November. I was on the island of Siargao on the east, Dubai in the UAE, South Korea. Cool, very many people. Germany, I see. Some people who are traveling, very cool. More people from Bahrain. Nigeria, cool. Malaysia, Canada, Saudi Arabia, cool. So many different countries represented here. Australia. It's nice that those of us with the similar interest here so many of us can be on the same Zoom call. This wouldn't have been possible 20 years ago. So you're living in the right age to learn mental math from this. Azerbaijan, Saudi Arabia, Pakistan. Okay, really cool. So very happy to have all of you here. Belgium, Pakistan, and I'm glad so many of you are participating in the chat, talking to us here. Mauritius, Sri Lanka. I visited Sri Lanka as well. Very nice. I was in Colombo and Marissa. Cool. Quite a few people from Sri Lanka. Okay, very nice. Thank you for the participation there. I'll ask you to be answering questions as well in some of the mental math questions. You can answer them in the same way like you did just then. Okay, very nice. So I'm going to share the whiteboard. The way Zoom has changed how the whiteboard works, which is a bit annoying. So I don't know. We've got the standard whiteboard here. So I'll start off with something that's very simple, but then I'll say some more advanced things about it soon. So can I have a volunteer write in the chat to explain how they would solve this question? So the answer, but I want you to volunteer to tell me how you solve this question. Okay, first person I see is Dipanshu. Dipanshu, could you explain, please, how you solve this method? How you solve this question? Are we able to hear from Dipanshu?
Dipanshu, I'm just trying to unmute Dipanshu. Just one moment.
Okay, yeah.
Yes, we have Dipanshu.
Cool, thank you.
Dipanshu?
Yeah, so we can do 34 into 8 by writing it.
Yes, and how do you solve this?
Yeah, so first I'll do 30 into 8,
Okay,
which would be 240.
Very nice, yeah.
Then I'll do 4 into 8, which will be 32. Then
Very
I'll
good,
add
yeah.
two. Then I'll add 240 and 32, which will be 272.
Nice, yeah. So this is cool. Thank you for that, Dipanshu, for being our first volunteer. And thank you to everyone else. I had maybe 20 people ask to volunteer, so I'm glad everyone is very keen here. This is the method I would recommend. We split the 34 into a 30 and a 4. We multiply each of them by 8, and then we add the result together. Simply like this. Many of the multiplications you have to do are going to be simple ones like this, in which case I would recommend doing a method like this. Some of you may prefer to start with 4 times 8 and afterwards 30 times 8. I prefer to do it this way, but if you are fast doing it the other way around, then this is also fine. I have another question here. So again, same thing, a volunteer to explain how they would use the same method for solving this question. Let's do 64 times 12. So type the answer and then afterwards tell me if you would like to volunteer. Okay, can we have Arav? Arav. Arav Thakur, please.
Hello, sir.
Yeah.
So I would use the same method. So first I would take but like I would use kind of different method. I would first take 10 and multiply it by 64, which would be 640.
Okay,
And
yeah.
then take 2 times 4.
Good, yeah. I'm going to change this around. So I'm going to do 64 times 10, and then we're going to
And
add
then
64 times 2, yeah?
yeah, which is going to be 128. Then I add them, which is going to be 768.
768. Nice. Good, yeah, thank you for that. So this is one method of solving this. Did anyone do a slightly different method? There's a few different ways of doing this. So a volunteer who has maybe a different method, type in the chat different methods if you want to share a different method. Okay, quite a few people are doing the same methods here. Can I invite Harsh Nahata to share a different method?
Nahata, Harsh Nahata. Yes, we have Harsh.
Hello,
Okay, very nice.
Daniel sir, and hello, Avinash sir. Hope you all are doing great.
Yes, Harsh. Thank you.
Yeah. So, sir, there is one more way. That is like I would be taking the average. It's quite a actually a bit bigger way, but that one is I would taking the average of both the numbers. That is 38, and then 38 plus 26 would be the one box, and then 38 minus 26 would be one bracket. Then I would be doing the like basically it would be 38 square minus 26 square.
Okay,
It would be
very
a
cool.
better one if it would be a better one if I know the squares of bigger numbers. It would be a more easier one. Right now it is a quite smaller number.
Okay, yeah. So this is quite a cool method. We're not going to have a too much look at today, called difference of two squares. So don't worry too much about this method, but thank you, Harsh, for sharing. So
Yeah, thank you,
this
sir.
is a cool method for certain types of multiplications where the numbers are close together. And almost by magic, if you do this subtraction here, you do end up with the, just checking, yeah, you do end up with the correct answer by doing the average squared, subtract the different squared. I'll come back to this idea later on. Thank you for sharing that. Can I ask Avyukt? Avyukt has another method for solving this. Can we invite Avyukt, please?
Yes, we have Avyukt.
AVY.
So first I would multiply 12 by 4.
Okay, yep. Just trying to type this, yeah.
And keep everything except the units digit as the carry.
Yep, okay.
Then I would add that to 6 times 12.
Good, yeah. So I'm going to present it a little differently, but the same idea. To get the final answer. So what Avyukt is saying is if you start doing the 4 times the 12, then you can already write down the 8 and then leave the 4 for later. This is going to be a really important idea when we do cross multiplication in a moment. And for small numbers, I prefer to do it the other way around. Both ways are working. You see, if you do Avyukt methods, then you don't have to think of the 0 in the 60. You just do 6 times 12 because you already wrote down the digits. So as long as you have, thank you for sharing, that's really nice. What I'm showing here is that there's several methods that have the same result, and it's important for you to pick one which is one that you understand and that you can do quickly. And the other thing I want to show is for the which fact do you need to have memorized for each of these? So here we needed to know that 3 times 8 is 24. We needed to know that 4 times 8 is equal to 32. Here for Avyukt's method, we needed to show that we needed to have memorized that 6 times 12 is equal to 72. Oops. We also needed 4 times 12 is equal to 48. We need to have these memorized. And for the first method here, we needed to know that 64 times 2 is equal to 128. Or we need to calculate it very quickly. And this brings us to one of the fundamental ideas in mental math, which is you need to have certain facts memorized because mental math just means combining these ideas together. Thank you, Harsh, for the fixing the typo there. Should be 68. Thank you. So we'll say more about this in a moment, but you need to memorize certain math facts. And for example, the times tables from 2 to 9, it's essential to know those very well. And if you also know 12, the 12 times table, which is what we used in the, is what Avyukt used in the second method for doing 60 times 12 and 4 times 12, that gives you more possibilities. It means you can choose an easier method sometimes.
It seems Rishidev also has another method. Do you want to have a look at that?
I think this is fine for now. Thank you.
Okay.
Thank you. There's many cool methods for these, and these are the 2 I want to focus on here. So we've got, we'll talk more about this later, but you really want to have certain math facts completely memorized so that whenever you're doing a calculation that requires them, you can get those numbers instantly. Unfortunately, we can't memorize all, well, not unfortunately, otherwise mental math would be very boring. We can't memorize the answers to all mental math questions. So when you're given something more difficult, like 34 multiplied by 8 or 64 multiplied by 12, you need to split one of those numbers into 2 pieces. And so for the black one, we were using the 8 times table by splitting 34 into different pieces that we could multiply by 8. We could do 30 times 8 and 4 times 8. For the blue method, the first line we were taking multiples of 64. For the second one, we were taking multiples of 12. If we know the 12 times table, that middle line is very possible as well. And so this is how I would recommend to solve all easy looking multiplications where you know multiples of one of the numbers. Unfortunately, it's not always so simple. Sometimes there's methods where you have to multiply two numbers that are so large you don't know multiples of either of them. So here's a more difficult example to try. What would be 74 multiplied by, let's do 27. 74 multiplied by 27. So answers in the private chat, and if you want to volunteer to explain your method, then after you've written the answer, please tell us that. I'll tell you some ways of memorizing math facts later on. I've had a couple good questions there. Cool. People telling me they know up to the 12 times table. Yes, we've got some correct answers here. If you have the correct answer and you want to share, if you have the answer and you want to share your methods, let me know as well. Nice. Yeah, a lot of people telling me their answers here. A lot of people have it correct. Few incorrect ones as well. That's also fine. Haven't had any volunteers yet. Some people saying they use the abacus. Yes, all of these techniques also work on the abacus. So if you use the abacus or the soroban, if you want to explain, you need to tell me the method first, please. So you need to tell me the answer first. So I know that I'm inviting someone who has the correct answer. Okay, haven't. So I've had a lot of messages from many people here.
But no right answer here.
A few right answers, a lot of incorrect answers actually. Looking for if someone wants to volunteer, someone has the correct answer and also wants to volunteer. Send me a message if you want to volunteer to tell me the answer. I haven't had anyone yet with the correct answer who has also volunteered. I've looked through about 20 of these. Okay, maybe Musa. Musa Mubin.
Musa Mubin.
And if you did send me, if anyone sent me a message, remember that I have more than 100 chat messages here, so I'm
Okay.
not seeing all of them easily.
We also have Rishidev Karthik, who's got the 1998 as the answer, and he wants to share a different
Musa
method.
Mubin, please.
Yeah, we have Musa Mubin.
Okay, thank you so much.
I did like 70 times 27
Good.
plus 4 times 27, or if you don't know it, just 27 times 2 times 2.
Okay, nice. And so what is 70 times 27?
180.
180.
No, that was
sorry.
4. That was 4 times 27.
Yeah. And how about 7 times 27? So you had the right answer here. So this is going to be 1,800.
1,890.
Very good. Yeah, nice. And then when we add those together, Musa, what's the final answer?
It is 1,998.
Very good. Yeah. Thank you so much, Mubin. Thank you so much, Musa Mubin. This is the correct answer.
Thank you.
And so we notice Musa has used the same method as we did before, taking multiples of 27. But calculating 7 times 27 is more difficult, and we have to think more during the method. And so what I'm going to show you today is an alternative method to this that means you never have to have too many numbers stored in your mind. And it's called cross multiplication. Does anyone, maybe I can have a volunteer who uses the cross multiplication methods. So if you send me a message saying cross, if you know the cross multiplication methods. And I'll have a volunteer to help me with that. So someone with the yeah,
We have a
Rupali?
Rishidev who does the cross multiplication method. Do you want me to unmute him?
Sure, yes, please.
He's been trying to get your attention.
There's 100 people here trying to get my attention.
Like, first we multiply 4 times 7.
Okay.
That is equals to 28. So first we write 8. Then we carry over the 2.
Good,
And
yeah.
then we
So this means that the answer ends in an 8. Good, yeah.
Then we multiply 7 times 7. 7 times 7. And then add it with 4 times 2. And then add 2. That is
good, yeah.
And that is equals to 59. So the
Okay.
second number.
And can you remind us, why are we adding 2? You're correct, but why are we adding 2 at the end?
Because it was the carryover for 28.
Good, yeah. So we need to remember the carry, and this is where we remember the carry.
And the answer is 59. So we write 9 and then carry over 5.
Nice, yeah. So 59. So I'm going to put this on a different line. Write the 9. Let's do that. The answer is going to be something ending in 98, and then carry the 5. Okay,
Then
good.
we multiply 7 times 2 and then add the 5 and the result will be 19. So we write 19 directly. So the answer will be 1998.
Why do we not have to carry anything here?
Because
correct.
this is the last number. Finished, yeah.
Exactly, yeah. So good, yeah. So this is the method. You can see how this is working, and this is called cross multiplication. I'll give an example now, showing you some more of the details of how I recommend to do this method. Thank you for sharing. Very nice. And so I'll pick the same example and explain how this is working and how I would recommend everyone to do it. If I can just get the right thing on my setting. Okay, here we go. This is the first big method from today. So it's called cross multiplication or crisscross for multiplying big numbers. For example, if I'm doing this number multiplied by this number, I can use cross multiplication to solve this, and this method will work. So let's take the same, I'll pick a different method. Sorry, a different question for this. Let's do 46 multiplied by 57. I'm going to write the question in this format here to make it a bit easier to present. So what I do, start with the right, which is what we've just seen as well. 6 multiplied by 7 is equal to 42. And notice, if I do all of the other, at some point in the calculation, I'm going to have to, like before, I've multiplied the 6 by the 7. I also need to multiply the 40 by the 7, which gives me 280. I also have to multiply the 50 by the 6, which gives me, actually, I want to change the question. I want to change it to 80. Yes. Okay. I have to do the 80 times the 6, which gives me 480. And I also have to do the 80 times the 40, which gives me 3,200. Now notice something here. In the first, all of these get added together to give the final answer, because 46 is 40 plus 6, 87 is 80 plus 7. So all of the different combinations of numbers need to be added together. So notice here, when I have 6 times 7, there's no 0. When I have 40 times 7, I have 1 0. So I'm going to put those in brackets. On the second one, I'm going to have 1 0 as well. And for the last example here, the 80 has a 0 and the 40 has a 0. And so for this reason, if we start with the right, when we get in 42, when we get this 2 here, we know that the 2 must be in the final answer, because the things we're going to add to 42 are 280 that ends in 0, 480 that ends in 0, and 3,200 that also ends in zeros. So this means we can definitely know that 2 is in the final answer. The answer must end in a 2. And at this point here, then, we can say, well, for the next digit after the 2, so this one, the digit before the 2, this is counting tens. You know this from school, that every digit moving to the left is worth 10 times more. When we calculate this digit, then we should look at the everything else in the calculation that is counting tens. So this 4 is counting tens. The 28 is counting tens. The 48 is counting tens. And on this one, there's nothing that's counting tens. We're still looking at the 0. And so this means we can just do the 4 times the 7 and the 8 times the 6, add those multiplications together, and also add the 4 from the 42. Those are all of the things that can affect the next digit in this digit here. And so how do we do that? What I recommend in the addition, and this is slightly different from what we've seen before, so I'm giving a recommendation of a slightly different method here. So for the next digit, I always start with the carry. This means you don't need to remember the carry digit during the calculation. So I start with the 4, and then I'm going to add the 4 times the 7. And that gives me 32. Because 4 times 7 is 28, we do 4 plus 4 times 7, and that gives me 32. And then I have to add the 8 times the 6. And that then gives me something. It gives me 80. So what I've done here, I've started with the carry, and I've found all of the combinations of 4, 6, 8, and 7 that when I have to multiply and are counting tens. And I'll show you graphically in a moment. There's a nice way of seeing this. So this means that the answer must end in, we have the 0 from the 8, so it must be 0, 2. And then we carry the 8. I'm going to add this here. Above here, we're going to carry the 4. Here we go. So at this point, we've used up the 40 times the 7, and we've also done the 80 times the 6. The only combination we haven't yet done is the 8 times the 4. So we've multiplied the 6 by the 7, the 4 by the 7, the 8 by the 6, but we haven't done the 8 times the 4. So again, we use exactly the same method. We start with the carry, which is in this case the 8, and then we do the 8 times the 4, and that gives us, I believe, 40. And at this point, we haven't got any other combinations we need to take into account. We don't need to consider any other combinations. So finished. So we write down these digits, and the answer is going to be 4008. I'm going to illustrate this on the diagram above as well. So the way I see this, looking at where I've written the question, you've got 46 times 87, and I put a green box around what we're starting with. So I'm looking at the right box, which is 46 times 87. Once I've finished with that, I'm going to move this box one space. I'm going to stretch it to the left one space, and this then helps me find the next digit. In this box, I'm going to start with the 2 corners. I'll do a star. I start with the opposite corners, so the 8 and the 6, and I multiply. I do it right now. Okay, I start with one corner, so this gives me the 7 multiplied by the 4, and then I multiply like this. I move in this direction. So after I do the 7 multiplied by the 4, where the stars are, I then move the stars in opposite directions. It's really important that they move in opposite directions so that I am multiplying all of the correct combinations of numbers. And so this here is where I get the 4 from the carry, the 4 times the 7, and the 8 times the 6, and to give me the 80 tens. After I've done this, let's remove the stars. I'm going to move this box one to the left, but I haven't got any more numbers. I can't stretch it more to the left. It doesn't make sense. So instead, I'm going to squash it from the right. So it's moving in the same direction, but now I'm squashing it. And now you can see in the box, I've got the 4 times the 8. So I'm starting with the 8 and finishing and multiplying it with the 4. And the box is very narrow. It now only has 1 digit in each. And so that tells me there's only 1 multiplication I need to add. So this is now on the last line. I start with the 8 because I always start with the carry. and then I add the 8 multiplied by the 4. So this is how cross multiplication works, and it even works when you have very large numbers. I'll take a quick break, a quick moment just to see if there's any messages people have here. I have a lot of messages sent here. So I'm just having a look at a sample of them. Yeah, question, is the group chat disabled? Yeah, I think the group chat is disabled. People showing me different methods here. Okay, I think everyone, people seem to be fine. Oh yeah, sorry, mistake there. It should be 4002. Thank you, Aroni, for correcting me, and maybe and Jessica, yes, thank you for correcting me. I wrote down the wrong answer there. By the way, you only need to send your message one time. Yeah, thank you, Dash, for checking it.
I was also confused there.
Yeah, so I wrote down the wrong thing. I wrote down the last digit rather than the first one. Sorry. Okay, cool. So now let's do another example with the same method, but we'll multiply together 2 bigger numbers. So we're going to go for 3-digit multiplied by 3 digits. So let's go for 456. 456 multiplied by 317.
21.
So see if you can try solving this method yourself. And meanwhile, I'll start writing the method here, and then maybe I can have a volunteer to continue this method. So again, we're starting from the right, which is 6 multiplied by 7. This means I have to write the 2. So in this place over here, let's put this in black text. I'm going to put the answer. So we know the answer ends in a 2. Next thing I'm going to do is I'm going to move this box. I'm going to stretch this box 1 space to the left. So at this point, the box is going to look like 56 and 17. So we add to the carry. What was the carry digits? The carry digit was 4 from before. And now I'm going to start in one corner of the box. So actually, usually I do this one. So 1 multiplied by 6, and I'm going to add that multiplication. 1 times 6. And because I don't want to have too many numbers floating in my brain, I'm going to write down the answer to, I'm going to think of the answer to this immediately. What is 4 plus 1 times 6? It's 10. What else do I need to add? I need to move these arrows in opposite directions. So I'm going to move the star from the 6 to the 5 and from the 1 to the 7. So this is now going to be 7 multiplied by 5. And this here, what's 10 plus 35? It gives me 45. This means then I should write down 5 and carry the 4. So again, it's a 4. So my answer now, I can write this as something, 5, 2. I can write down the 5 now as well. So we've got 2 digits from the question. What do I do next? Well, I always try to stretch the box one space to the left. So now the box is really big. The box is using all of the digits, actually. And again, I'm starting with the opposite corners of the box. So what shall I write? Stretch box one digit to the left. And now the box looks like 456 and 317. Add to the carry. The carry was 4. It's changed from 4 to a different 4, so we still have 4 actually. The first multiplication is going to be the opposite corners, so 3 times 6. What is 4 plus 3 times 6? 4 plus 18 is going to be 22. And then I'm going to move the star one space. So I'm going to put a cross, put a tick. So it moves in this direction. So I'm now multiplying the ones where the star has moved in the opposite directions, and I've replaced it by a green tick so you can see it. And so this here is then going to be 1 multiplied by 5. When I add that on, that gives me 27. 1 times 5 is 5. I'm doing 22 plus 5 to give me 27, and I haven't finished because I can move the box even further in this direction where I put the heart symbol. And for the hearts, this is then going to be plus a 7 times a 4. What's 27 plus 7 times 4? I think it's going to be 55. So I write the last 5. I write down the last 5, and then I carry the first 5. So at this point, the answer is going to be, it was ending in 52, now it's 552. What's next? Let's remove the symbols here. I can't move my box. I can't move the box any further. Oops. I can't move the box any further to the left because there's no more digits. It doesn't work. So instead, I'm going to move this box, making it smaller from the right. So I'm still moving this box. So I was shrinking the box still towards the left by shrinking it away from the right. So we're always moving from the right to the left. And this gives us then the box 45 multiplied by 31. So what do we add to the carry? Or what is the carry? Carry is 5. What do we add to the carry? Again, it's the opposite corners. So it's going to be the 3 times 5. And that gives us 20. And then the 1 multiplied by 4. And that gives me equals 24. Again, I write the last digit, which is the 4, and carry the first digit, which is a 2. And this is using too much space on my whiteboard, so I have to move it. Okay. So at this point, we're nearly done. We're nearly done with the multiplication. So the answer is going to be, it was 552, and now I can put the other 4 down there. And I shrink the box one more time towards the left. And at this point, it only has 1 multiplication. It only has the 4 times the 3. So this stage should be really easy. So shrink the box towards the left. And so it's just going to be 4 times 3. That's all that's left. add to the carry. I've got 2 that I carried, plus 3 times 4. I guess here I should just put and. And this here gives me 14. So we're finished now, so we can just write down all the digits, and that will be the correct answer. So the answer was something 4552. We now just put the 14 beforehand, and that there is hopefully the correct answer. Okay. So I'll just check everyone's messages. So yeah, very good, Dash. You have the correct answer. Also the correct answer from Musa. Well done. There are some other methods for doing this. So we can take multiples of 456. I'm recommending this method because this one will always work. This method here works even when you have really large numbers. Okay. I'm just checking
And to
the
those who,
messages coming through.
I do get some messages where people say it's a very long method, but what you have to remember is it's all about practice. If you want to do really big multiplication, and this is just, when it comes to mental calculation world, this is not even a very high number, 456 by 317. A 3-digit by 3-digit is not a really big number. People do even 10 by 10 digit multiplications nowadays. So the point of the matter over here is that, it's about practice. If you keep practicing this method, it'll start becoming easier. You'll reach a stage when you'll be able to do it mentally. And that's the only way to do it. Practice, practice, and practice. That's all done.
Thank you. Yeah, and that's very much true. And I'll do a demonstration in a moment where I'll do it with some larger numbers, and you can see that with my practice, it's really possible to do this quite quickly, even with larger numbers. There's a competition in Germany open to people of all ages, and for this method, people are doing 8-digit times 8 digits. For those of you doing the Grandmaster level, then your multiplications are usually quite easy, and so you'll get 2-digit times 2-digit. For those of you doing Zenmaster, or you want to do more advanced mental calculation methods in the future, then this is one of the most powerful methods. All of the people who have the world record for multiplication, all of the people who have the world record for multiplication, they are all using this method, for sure. Just reading the last one. So this is the easiest methods when you have which works for numbers of any size. I think what I'm going to do is I'll go on to the demonstration now for this, so that everyone can see, so you can see me doing this method basically. So this is one of the apps I use for training, and it's going to give me some multiplications. So this is 6, 4, 25, 2, 14, 28, 3, 6, 9, 3, 3. So you can see here, I'm solving 4 digits times 4 digits in less than 20 seconds. And I'm using exactly the same method as I'm doing here. I'm not even super fast. There are some people who can do it even faster than this. All it requires is working systematically from the left to the right. Let's do another one, but I explain my method a little more. So here I'm starting 1 times 3 is 3, no carry. 9 times 1 and 8 times 3 is 33. Write the 3, carry the 3. 3 times plus 9 plus 1 is 12, plus 8 times 7 is 84, plus 3 times 6 is 102. Right, 2 carry 10. 10 plus 8 plus 9 times 8 plus 9 times 6, 144, plus 3 times 7, 165, 16, 80, 80, 134, 197, right 7, carry 19, 19, 67, 130, 130, nearly got that one wrong, 13, and then add the last digits in. So you can see how I'm working systematically from the left and the right, from the left to the right, always just considering the box and doing the multiplications within the box. So I recommend practice this method with smaller ones so you understand it. And then whenever you have a multiplication that's too hard, too difficult to do with your current methods, then you always have this as a possibility. If you want to read more, about this method, then I have a page. This is from my website, actually. This is a page from my website. I've put the answer in the main chat for everyone. I think you can't respond, but I sent the message to everyone. This is an article that I wrote that explains the same methods, so you can refer to this later if you want to learn this cross multiplication method that works for large numbers. Meanwhile, we're going to move on and have a look at some shortcuts for different types of multiplications. For example, square numbers. So there's 3 methods that I like for multiplying square numbers, and maybe some people here have one of those methods. So if you'd like to share a method for square numbers, then can I please have a volunteer? So write the word squares in the chats, and the first person I see who writes the word squares, I'll invite you to do that. Yeah, some people saying that they can't, they find mental maths difficult, even if they can do it on paper. Okay, so we have Simone Dominici. Can we have Simone, please? Thank you for volunteering.
Simona.
What is the
Yes, we have
question?
Simone.
Sorry. What is the question again?
Yeah, what method would you use for finding square numbers? And I'll give you an example. Let's try 57 squared. So what method would you use for calculating something like, okay, can we unmute Simone, please? He's muted.
So first I would do 50 times 50, and that is 2,500, I think.
Yeah, that's correct. Very nice.
Next, I would do 7 times 7, and that is 49. And then I just add those together, and it makes 2,549. And that should be the answer.
It's almost the answer, but we're missing one part actually. So this is almost the methods. Remember when we're doing the when we did the crisscross methods, the 57 times 57, we started off by multiplying the 7 times the 7 in the box, which is the last thing that Simona has done. And then in the end, when we moved the box, we had the 5 times 5 at the left-hand side. But in the middle, we had this case here, where with the cross multiplication, we start with 5 times 7, and then we have to add on a 7 times 5. So in this method, there's also an extra step in the middle where we've got the 5 times 70 and
which is
70.
350, I think.
Nice. Yeah, very good. It is, yeah. And then what 70 times 5?
70 times 5 is also 350.
Yeah. So it's the same. We've got the same thing twice here. So this here altogether is 7 plus 700 to give 3,000.
249.
Good, yeah. And then so when we add the 7 times the 7, then yeah, it's exactly what you said. Very nice. 3,249. So this is one of the 3 methods of doing it. We can do it like the crisscross method, but in this case, because they're quite easy, I say we can do it backwards. And I'm actually copying from Ayush here. Those of you who've seen algebra before, we're using this logic here. So if this makes sense to you, this is one way of seeing it. I'm just going to do the formatting. We're using this logic here. And so what this means is that when I'm doing if I do the cross method, when I get to the middle part and I have to do the stars multiplied by each other, and then the other diagonal, those numbers multiplied by each other, the answer is going to be the same because it's like 5 times 7 and 5 times 7. It's both the same. So in that case, I can just double it. So it's like 50 times 50 equals 2,500 plus double of 5 times 70, which is 700, which is 3,200. I'm just writing the same method in a different format, plus 7 squared, which is 3,249. Just to be completely clear, this is talking about squares. 57 squared means 57 twice multiplied together. So I've got 57, I've got two 57s, and I multiplied them together. That's what this means. There's other methods for doing multiplications for square numbers. Does anyone have a different method? This is one of the 3 methods I was going to show you. If you write squares and then the word different afterwards, write the word different after the word squares. Anyone who writes different and then squares? Okay. Can we have Taman? Taman Subin. T-H-A-M-A-N. Taman. Taman's going to show us maybe a different method for calculating square numbers. Are we able to hear from Taman? Yeah. Is it possible to unmute Taman, please?
Daniel, can you spell Taman for me?
T-H-A-M-A-N.
T-H-A, Taman. Taman Subin.
Yeah.
Yes, we got it.
Exactly.
Okay, thank you, sir.
Cool,
So
thank you.
I have, for me, learning squares, I'd say that up till 20 is actually a good amount to first memorize because knowing squares of previous numbers up till like maybe 15 or 20 is manageable because you can use that as knowledge to try and like figure out other ones. Similar to what we saw in the previous method, but we use a bit more memory in it. Like if I was to do the 57 squared one, I would use a bit of the crisscross method, but I already know the answer for what is 50 squared and what is 7 squared. Since I know that 5 squared is 25 and there's 2 zeros, add the 2 zeros at the end and you get 2500. So we know the square of 50. And for 7, it's pretty obviously going to be 49. So then, as we already have those two, all we have to do is do 2 of 50 times 7. Do 2 of 50 times 7. Then I'll add all those together and I'll get the same answer, 3249.
Okay, nice, cool. Thank you for sharing, Tama. So 2 comments here, both valuable. One of them is that you can add the different pieces in method 1 in any order you like. So Daman has started with 50 squared and 7 squared, and then does the middle part afterwards. Actually, I don't prefer it to do this way, but it's up to each of you when you do the calculation. And the second thing is, if you want to, you can just memorize the square numbers. Remember we said earlier, it's important to have some numbers memorized, like the multiplication tables, the times tables, so that you can do mental math quickly. Well, if you want, you can remember all of the square numbers up to 99 squared. And if you do that, all of the squares questions and actually all of the square roots questions in the Mental Math World Cup will be super easy because you will know the answer without doing any thinking. You can be super, super fast. You have 0 calculation required. I also memorized all of the squares actually up to 99 squared. And the reason for this is for the more advanced methods with square roots and mainly for square roots, then I'm using them all the time. Sometimes I have to do square roots with many decimal places or square roots of 8-digit, 9-digit, 10-digit, maybe 12-digit numbers. And so for this, knowing the 2-digit squares is really important. You don't need to do it for the Mental Math World Cup, but if you memorize some of them, then that gives you an advantage for certain questions. The question was 88 squared, 7744. Just checking a couple of the messages. Different. Okay, I'm going to show a third method now, which is really cool. So the logic for this is that if I do x plus y squared, so those of you who've seen algebra, I'll show you the algebra logic first, and then I show for everybody the method. This is going to be x multiplied by x times y plus, well, it's y multiplied by x plus y. This multiplies to xy plus y squared. And the xy is also a factor of x. So I'm just going to put it in this bracket. So I'm using this logic. So for 57 squared, x is 50 and y is 7. So I can do this as 50 multiplied by what is x plus 2y? It's going to be 64. And so that there is 3,200, yeah. And then I just have to add the 7 squared at the end, which we've already seen is the correct answer. So this is a nice shortcut for doing square numbers. Let's write it down as a method so it's easy to understand. So step 1. So round to a nice number. So for this here, I can do 57. I can round it down to 50, or I can round it up to 60. Step 2. Adjust it the other way too. So in this case, if I've changed it down by 7 to 50, then I have to add 7 to get 64, or I have had to do 57 minus 3 to get 54. So 2 different ways of doing this method. Step 3. I multiply them and add the adjustment squared. So what does that mean? In this case, it would be either 50 times 64 plus 7 squared, or if I'm doing it with 60, it would be 60 multiplied by 54 plus 3 squared. In both of those cases, I'm going to get the correct answer of 3249. And so this is a nice shortcut when you have to do squares with mental math. It only works for square numbers. Let's try another example like this. And so see if you can do this method. Don't just tell me the answer, but I want you to write down you're working for step 3. So for example, 50 times 60 plus 7 squared. Write the logic in the chat for the following question. How would you do 88 squared? Yes. So write down the method for step 3, which should be something multiplied by something plus something squared. So I'm not looking for the answer. The answer is 7,744. I've already told you. I want to know what the method is to see who understands doing this method here. We want to change 88 to a nice number. There's a few possibilities, a number that's easy for multiplying by, and then however much you change 88 up or down, you need to also change 88 the other way, down or up, multiply them together, and add the square of the adjustments. Okay. Right. Some of you are sending me like 100 messages that are the same. I'm not going to read those. Okay. So we have there's 3 ways of doing it actually. One correct method by Daman. Another, yeah, Divij, very good. Dipanshu, stop sending me messages like that. It's rude. So Daman and Divij. Those are correct. Sanitha. Okay, very nice. Can we ask Daman again? Yeah, Daman, Sanitha, and Divij, please, to just share their methods, because there's three ways of doing this, and each of you have got the correct way.
We have Taman. Right
Okay.
now.
Okay. And maybe unmute the
Okay.
other 2 in the same time just for speed. But yeah, Daman, yes, please.
Okay, so I had used your third method by first looking at the formula and changing each of the values by substituting the variables. I start off by saying using this exact formula and changing x to be 80 and y to be 8.
Very
So
nice.
if you look at your logic, it would be x in times x plus 2y plus y square. So if we were to start off with x, which would be 80, then we put in brackets 80 times 2 of 8, which is going to be 16. So 80 times 80 plus 16.
Which is 96. Good, yeah.
Then after that, we have to add in y square. And 8 squared is going to be 64. So 80 times 96 plus 64.
Very nice. Thank you very much. So this is one way of doing it, and gives us 7744, which is correct. What did we do here? We changed 88 to 80. That was the idea here. There's two other good ways of doing it. Can we hear from either Sanitha or Divij, please?
We have Divij already, and you said Sanita, right?
Sanitha, yeah, perfect. So Divij, how did you do it?
I used 100 because 100 is generally easy to use. So I did 100 into 76 because it's minus 12, so minus 12 again, which would make it 76, plus the differential squared, which is 12 squared, which is just 7600 plus 144, which is easy to do.
Very nice, yeah. Very nice. Cool, thank you. And Sanitha, please. You had another way of doing it.
Okay. So I read a book called The Secrets of Mental Maths, that to square 88. I had to round up by 2 to 90, and then I had to round 2 down to 86. And then I had to multiply 86 by 90, which is just 86 by 9. So I multiplied 80 by 9 to get 720. Then I did 6 times 9 is 54 to get 774. And then I just added a 0. And then I added the square of 2, which is 4, to get 7,744.
Very nice. Cool. Thank you very much.
Thank you.
So yeah, so 3 ways of doing this method. Which is best? I mean, it's up to you. They are all good ways of doing it. I would do it with 100, but it's maybe more natural to do it with 80, and it's also the smallest difference if we use 90. So it's all good. I'm just explaining here where the differences come from here. So this here is a shortcut for squares that works for, especially good for 2-digit and 3-digit squares. I'm just figuring this part out. Okay. 88 minus 12 equals 74, and that gives us this. Okay, very nice. So here are these are some shortcuts for calculating square numbers. Next thing we're going to have a look at is square roots. Abhinav, did you want to have a quick break now, or did you should we do square roots first quickly?
I would leave it up to you. If you we'll be taking another break of 10 minutes. Is that
okay? Let's finish the squares. Let's finish the square roots, and then we'll have a quick break. Yeah, I think that sounds good. Okay, so what does a square root mean? Square root is like if someone gave you a number, if someone thought of a secret number and they squared that number, maybe using one of the methods we talked about today. If they square that number and they tell you the answer, like 7,744, your challenge for a square root is to do the opposite and go back and find what the number was that they squared. And there's a lot of really cool advanced methods for doing square roots. For the Mental Math World Cup, you only have to do square roots up to 4-digit numbers, and that means that the answer will be 2 digits. So that's an important trick to always know. If I square a 2-digit number, the answer is 3 or 4 digits. So a square root of a 3 or 4 digit number, the answer must be 2 digits. Usually, the square root of a random number has a very complicated decimal at the end. For the questions in the Mental Math World Cup and also in some other competitions, the answer is always going to be an integer. So how do we do these? If I go back to the previous slide, we look at method 2. Method 2 was just memorize them. So if you memorize the square numbers, it's super easy. You just know the answer already. Otherwise, we have to do a little bit of thinking, but actually square roots, they might sound very scary, but they're very easy. The square roots is some of the easiest questions you have to do when you learn the method. So I'll give an example, and I'd like a volunteer to you type the answer to me, and if you want to volunteer to share the method, then also say afterwards you want to volunteer. So what's the square root of 5,929? So write the answer, and if you want to share the answer, then also tell me that you want to share. I also see lots of good methods for other stuff. Okay, I'm getting nice, yeah, getting some answers in. A lot of people who don't want to volunteer, that's totally fine. But it's nice to have as many people sharing their answers as possible. The answer is not 27. I have some people saying 27. The answer is larger than that. Can we have Devash, please? Devash. Can I invite you to share your methods? You're one of the many people with the correct answer here.
Yeah, we have Devansh Patnaik, right?
Devarsh. Devarsh Sathish.
Devarsh.
Yeah, Devarsh Sathish.
Okay,
please.
we have a Devarsh, yeah. Yes, we have Devarsh.
Hello, sir.
Hello.
Yeah, so the number is 5929. So what we can do, we can take the last two numbers, which is 29, and we'll check the units digit of that, which is 9. So then we check in which in which number square 9 comes in the units digit, and that is 3 and 7. As 3 square is 9 and 7 square is 49. Both of them end with 9. So we remember both of those numbers. And next we check for the first two numbers, which is 59. And we check in between which two squares that number comes. So we can see that it comes in between 7 square and 8 square, since it's between 49 and 64. So then what we do, we multiply it with both of those numbers. We multiply 7 and 8, which is 56. And then when you check, you can see that 56 is smaller than 59. So you take the smaller number. And then you take a bigger number, which is 7. So the answer is 77.
Very nice. Yeah, very good. This is exactly the method I was going to explain today, which is it's not the method that I usually use because I remember the 2-digit squares and I have to do other things. But this is the method I think is most valuable for those of you listening here who are going to be competing in the Mental Math World Cup. So I'm going to start with what I'm writing now. How does 59 compare to 49 while it's greater? Why do I care about 49? Because 49 is 7 squared. So because 7, it's not writing, because 7 squared is 49, it means that 70 squared is equal to 4,900 or 4,900. And our number is 5929. I don't care about the last two zeros because 70 squared has two zeros at the end, so I'm only looking at the 59. 8 squared equals 64, so 80 squared is equal to 6,400. This is too big. This is too small. So I know the answer has to be between 70 and 80. That means that the first digit needs to be between 7 and 8. So it needs to be 7 with another digit afterwards. Okay, so this means that the answer is in the 70s. Let's move that. Put that here. Okay. So now we know the answer is going to be 73 or 77. But which one? How do we know which one it's going to be? There's a trick here, which is exactly what Devash was explaining. We try 7 times the successor of 7. Now compare that to 59. Because 59 is larger than 56, it means that answer the larger one. So it's going to be 77. It's going to end in a 7, not ending in a 3. So this is the logic for this example. Let's put this as a series of steps so that you can follow this method. So exact square roots of exact square roots of 3 and 4 digit numbers. So ignore I'll use the same example. So ignore the last 2 digits. And that gives us 59. Compare 59 with square numbers. Seeing it's between 7 squared and 8 squared means the answer begins with 7, but there's going to be 2 possibilities in the 70s, and that's a problem. So I need to check whether it's closer to 7 squared or 8 squared. And in this case, it's closer to 8 squared, so it must be the larger of the possibilities. Or we can do what Devash said and say, if not sure, compare with 7 times 8. So once I've done this, I just need to work out what is in which possibility in the 70s it's going to be. So step 2, look at the last digit, which is 9. This means that the answer ends in 3 or 7. And because we know it's going to be the larger option, and because it's closer to 8 squared, because it's the larger option, then it needs to be the larger of these 2 options here. Let's try another example with this. In the first asterisk, the root ends in, thank you, yes. Thank you, Arish, for the correction there. The root ends in 307. Thank you. Okay. Cool. A lot of people volunteering. Very nice. I see, yeah, a few people with a similar name. Thank you for all of the volunteers. And yeah, very nice, Sanitha. Good explanation that you've written out for this. Okay, very nice. Let's try one other example. And so you can all try this. So what would be the square root of 1156? So answers in the private chat. And if you're using the same method as me and you want to explain, then you can tell me afterwards that you want to explain, that you want to share that method. Okay, good. We've got some good answers coming in. Can we have Jaden, Jay, Jaden, please? Good, yeah, lots of correct answers coming in. Can we invite Jaden to speak?
What you need to do is you need to take off 56, like you said. Take the last digits as per the root. For example, if it's the second root, you take out the last two digits. Okay. And then you need to find out between which two numbers squared 11 comes in between, which we know as 3 and 4, as 3 squared is 9 and 4 squared is 16. And as it's closer to the small number, and then there's only two numbers they can square to 6 at the back, which are 4 and 6. The answer is the smaller number, so it's 34.
Very good, yeah. Can you explain again how you knew it was the smaller number?
Well, it's closer to 3 squared, which is 9, rather than 16. So that's how I got the small number is 34.
Good, yeah. So it's I would say it's kind of obviously closer to 3 squared, or what we can do, we can compare 3 times 4 equals 12, and we can compare 11 to 3 times 4 and see that 11 is smaller, and this tells us that it's going to be the smaller root. So it's the next thing we know ends in 6, means the root ends in 4 or 6. It's the smaller possibility. We know it's the smaller possibility for the last digit. We just check that. So the answer is 30 something, 34 or 36. It's going to be 34. Okay, very nice. We'll do, yeah, good. 34 is correct. I'll do one more possibility because there's something that may trick people sometimes. So square root of 625. What's the square root of 625?
25.
Okay. Can we invite Jamal, please, to answer this one? Jamal.
What?
Yeah, Jamal.
So first you look at the last digit, which is 5.
Good, yeah.
5 then
I'm afraid we can't hear you very well, Jamal. Thank you for volunteering, but I really can't hear with the audio here. Sorry about that, but thank you. You have the correct methods. You have the correct answer for sure. If I find someone else who volunteer, sure. Can we have Daman again, please?
Okay, thank you, sir. So first of all, I was immediately looking at the last digit, and I noticed that there is a 5 at the end. And unless you have any number that's not a square, the only square would be a 5, since 5 times 5 is 25. So we already know it's only 5 it can end with. Then along with that, we have to compare it, because if we I just did some trial and error after that with using the different square values. I know that it has to be less than 35, because I tested out 35 immediately and realized it is more than the actual answer, which is 625. So when I realized that it was supposed to be 625, I had done 25 times 25, which had given me 625. It includes a bit of trial and error, but it worked out well.
Okay, so you see how because Daman knows some of the square numbers, he can find like some different shortcuts. So the more math facts you know, then the more shortcuts you have. Okay, good. Thank you for that. So what if we don't know them? We can just remove the last 2 digits to leave 6, and then we compare 6 to square numbers. And this one is between 2 squared and 3 squared. So that means the answer is in the 20s. So that means if it's in the 20s and ends in 5, the answer is going to be 25. Okay, so that covers the what we do with the square roots. I'm just going to do one quick thing as a demonstration, and then we're going to take a little break. So I'm kind of cheating here because I know the answer, but I'm going to try and calculate the square root of this large number. What I'm going to do is I'm going to remove lots of pairs from the beginning until I have a small amount left. Use memorized squares. I know that 6803, this is less than 83 squared, and it's more than 82 squared. So this means the answer is 82,000. It's in the 82,000s, basically. Then I do a special trick that we haven't seen here by checking 82 squared, comparing it to 82 squared or 83 squared. 82 squared I've memorized as 6,224, so this is about 80 more. I do 80 square it, 80 halve it, divide it by 82, and I end up with something just less than 4. So I know it's just under 82,500. And then look at the last 2 digits, 61. And from this here, I know that the ends in either 19, 31, 69, or 81. So because of this, I need to do the division step a little bit more precisely. And what I end up doing when I do this step, I end up with this being approximately 82,480. So from these possibilities, the only one that makes sense must be the 82,481, which is correct. So this is much more advanced than you need to know, but I just wanted to do a quick demonstration how this extends to the kind of calculations that, how this extends to other types of square roots. Here I'm using the memorized squares. I'm using the idea of looking at the left of the question and the right of the question, blocking off pairs of 2 digits from the right, but I also have to do this division thing that I haven't explained for doing this. If you're interested in learning more of this, we haven't got time to do it during this workshop, but I'm going to drop you a link for this copy. Yes, yeah. I'm going to drop a link here in the main chat so that you can try that. So if you want to learn this at some point, this is a more advanced method for really big square numbers. Okay, let's take a little break. Abhinav, how do you want to do that?
I think we'll just take a 10-minute. I think we can just join back in 10 minutes and start again with the cube roots, I guess.
Yeah, we've got the cube roots and the highest common factors and a little bit about the division and some other tricks. Those are the things that
Sure.
we're going to cover in the second half.
Sure. Let's just quickly take a 10-minute break. Everyone, you can just go get refreshed and come back. We will be back again in another 10 minutes. That's 5:27 my time. So let's just join back in 10 minutes.
Okay.
Yeah.
Yeah, I think we're starting again pretty soon.
Hello, everyone. Prakyat, are we back?
Yes, we're back.
Okay.
Okay. Do we need to wait for people to rejoin, or should we start? Should
I think we can start.
already?
Yes, let's start.
Okay. So we just talked about square roots, and I'm now going to talk about cube roots because they have a very similar method. And so like before, we said it's important to know the square numbers. It's important to know multiplication facts and a few other things. It's important to know the cube numbers from memory. So you need to know these. So 1 cubed equals 1. 2 cubed equals 8. And while I type these, notice a pattern. The last digit is always different. 1 cubed ends in 1, and it's the only cube number up to 10 that ends in a 1. 2 cubed is the only one that ends in an 8. 3 cubed is the only one that ends in a 7, and so on. And this helps us a lot when we calculate cube roots. Because just like for the square roots, we looked at the last digit, and that told us what the last digit of the square root was going to be. We can do the same thing with the cube roots. So I'll give a demonstration with, let's say, this one here. So the method is going to be very simple for to the square roots. So before, for the square roots, we take off a bunch of 2 digits to the end, but this is cube roots, so we take off groups of 3 digits. So block off groups of 3 digits from the right. So 54, 8, 7, 2. Look at the left and compare with the cubes. So in this case, where does 54 appear in the cube numbers? We see that 54, it's greater than 3 cubed, because 3 cubed is 27, but it's less than 4 cubed. So that means that the answer must be in the 30s. Step 2. Look at the last digit, 54,872. Ending in a 2. Looking at the table here, the only cube number that ends in a 2 is 8 cubed. So the answer ends in 8. So it's in the 30s and it ends in the 8. So that's the answer, 38. And that's it. The only 2 things you need to do the cube numbers are to memorize these, the cubes that I have in dark green, and then do this 2-step method. First step, to find the tens digit, that's the digit on the right, and the other method to find the digit on the left. That's it. Yeah. So a question from Debanch here, yeah, does this mean that the cube root is easier than the square root? Yes, cube root is easier than the square roots, actually. I mean, you can find cube roots of very long numbers, but even finding the cube root of like a 9-digit number is actually not so difficult. For the Mental Math World Cup, you only need to do square numbers up to sorry, cube roots of numbers up to 6 digits. Let's try a couple of examples of these. So I've got a few people answering. I'm going to give a different one now. So I'm going to try, let's say, this one. Okay. What's the cube root of 79,507? So people already answered yes. So people very fast. Will the first digit of the cube root always be the lesser number? Not always. Okay, yeah, and if you want to volunteer, then let me know. Yeah, a lot of answers so far. I think all the ones I've seen so far have been correct. Very good. And then I think we have Jaden to volunteer, please. Can we unmute Jaden, please?
Unmute.
Yes,
So
we have Jaden.
what you need to do is you need to take off the last 3 digits like I told you. For example, as per the root, you have to take off the last number of digits. So since this is cube root, take off the last 3 digits, and then 79 comes in between 4 cubed and 5 cubed. And as we know, the ending digit is 7. It means 3 times 3 is 9, and 9 times 3 is 7. So the ending digit is 3. And since it comes between 4 and 5 cubed, then that means 4 is the tens digit. So the answer is 43.
Very nice, yeah. So we know it's in the 40s, and we know it ends in a 3. So the answer is going to be 43. Cool. Thank you, Jaden. That's exactly right. Let's do one more example, and then I give you a couple of resources, and we move on already to the next topic. So let's do a really difficult looking one. Let's do, let's do this one. So 551,368.
No, type click, 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 click.
So
82.
I'll let people type in the answer. I'll let everyone type in the answer, and then I'll select a different volunteer for this. So type me the answer, and if you want to volunteer, tell me that you volunteer, and I'll select a different person who volunteered. Can we unmute Zidane, please? Zidane. And thank you for all of the other people offering to volunteer as well. But I'll ask Zidane for this question, please.
We have Zidane.
Yeah, so you just have to for the last 3 digits it ends in 8. So because it's 8, that means it must be the cube root of the number that ends in 2, and then
Good, yeah.
and then the first 3 digits 551, it's in between the cube roots of 8 and 9. So we take the smaller one, which is 8. So in the end, you get the answer 82.
Very good, yeah, that's exactly right. So the 551 tells us it's in the 80s, and the ending digit 8 tells us that it's going to be it's going to end in a 2. So it's 82. Okay, very nice. So cube roots is quite easy. You just need to memorize the cube numbers table, and there are methods for solving longer cube roots. So in some competitions, people are finding cube roots even of 12 digits, 12-digit numbers. And the method is quite similar to this. So I've just put in a chat, an article that I wrote that goes into more detail with more advanced methods about cube roots. Okay. Okay, So I think we're done with the cube roots. Next thing I'm going to have a look at is division. So imagine, I'll do something a bit different, right, for division. Imagine that we have a calculation here, but of two very big numbers. But some of the numbers, we can't see them because maybe there has been some ink spilled on the page, so we can't see them. So we just know that it's something ending in a 4 multiplied by something ending in a 7. So what would the last digit of this be? What would be the last digits? We can't do the multiplication because we can't see the numbers. So just type the answer. We only know the last one digit. The other digits we don't know. So think of the cross multiplication method, for example. We know for sure that this is going to end in an 8. Yes. So now imagine this, that we've got some numbers. We don't know what these numbers are. When we multiply them together, the answer ends in an 8. So my question is, what are the last digits? What are the possible last digits here? It could be 8 and 1. It could be 1 and 8. It could be 2 and 4. It could be 7 and 4. What other possibilities are there? Good. So we said it could be 6 and 3. It doesn't matter which way around it is. So 1 and 8, 2 and 4, 7 and 4, 6 and 3. Any other possibilities? 8 and 1, 7 and 4, 2 and 4, yes. 9 and 2. Good, yeah. 2 and 9, good. 1 and 8, 6 and 8, yes. So it could be 8 and 1, 8 and 6. It could be 2 and 4, 2 and 9. Let's put them at the beginning. Which other ones can we find? 6 and 8, good, yep. So it could be 6 and 3. It could also be 6 and 8. It could be 7 and 4. It could also be 4 and 2. And those are actually all of the possibilities. So some things to notice here. Can anyone see a pattern between each of these pairs of numbers? What's always the pattern here? And say volunteer afterwards if you want to volunteer to tell everyone. And I only ask you to volunteer if it's correct. Yeah, let's take Jamal Musyoka. Jamal Musyoka from Kenya.
Can we have Jamal?
You add 5.
Good, yeah, they're always separated by 5. Thank you. And so why is this important? Now imagine if I told you that if we have a look and we see that one of these digits is, for example, a 4, that means that this digit must be a 2 or a 7. So what we're doing here is we're doing detective work to do the opposite of multiplication. But the opposite of multiplication is division. So what I've actually shown you here is a shortcut for doing exact divisions. So what I can do, if I have a calculation like this, now if I do a different one, let's say ending in a 6, sorry, something ending in an 8, dividing by something else. Should I do it this way around? Question marks. So a number ending in an 8 divided by something ending in a 4. What are the possibilities for what this is going to end in? What are the possibilities for this digit? And show me all of the possibilities. I want to know all of the possibilities. There's at least two different possible numbers. Good, yeah. Can we have and always say volunteer at the end if you want to volunteer. Okay, let's have a Major. Major Singh Sandhu.
Yeah,
So
we have.
the two numbers are 2 and 9, sir.
You said something different. You mean something
Oh
else
yeah,
for
sorry,
sure.
sir. 2 and 7.
2 or 7. Thank you. Yeah, exactly. So we know it's going to be 2 or 7. And this is really helpful then for division because can you mute yourself again, please, Major? Thank you for the contribution.
Okay, thank you.
So this means that if we know the answer is going to be a whole number, which is what happens in these competitions, then for sure you can look at the last digits to tell you what that's going to be. Let's try an example, like a real example with this. So what's going to be 3,854 divided by 82? So what would be the answer? And if you have a good method using this idea, then please volunteer. So this is a trickier question. Getting some answers in. If you send me a million messages, I'm not going to read them. Okay. Can we have Aliza? Aliza Iqbal, please.
Yes, we have a Lisa.
Hello, sir. I'd just like to know if you can hear me first.
Yeah, hear you very well, thank you.
Thank you. So, my method is basically in grade school, we had learned about how when you're dividing something, an easy way to do it is by, like, let's say there's a division like 3854 and 82. First, we could simplify it by finding like numbers, like factors they have in common. Like, for example, I noticed that 3854 and 82, obviously the biggest factor that like I could find at the spur of the moment was 2. So first I did that. So I simplified it, right? And I just tried to simplify as much as I can. And then I divide it so that the numbers like will be smaller and then it's easily divisible. And that's how I got like 47.
Okay, so you simplified it to 1,927 first.
Yeah, that's what I did. And then I divided it and it was easier for me in that way.
Okay, nice. So if you see a simple simplification, for example, if both numbers end in 5, or in this case, they're both even, one option you've got is to simplify, so simplify the division. Usually you see this with fractions. Fraction is just a division, so it's working the same way. Okay, nice, cool. Thank you, Aliza. I'll show you the method that I would do for this. First of all, I would just estimate, because it's small, I would just estimate what the first digit is going to be. And so if I do 82 times 40, this is going to be 3,280. So the first digit is going to be a 4 because that's a bit less. And I can also do 82 times 50 equals 4,100. So whichever way you want to estimate the division, it's up to you. So this means then that the answer is in the 40s, close to 50. So I'm not focusing on the method here. Anything you want to get the first digit is okay. The thing I want to focus on is the last digit, because this is the biggest trick. So ending in a 4, dividing by something that ends in a 2, this means that the answer ends in 2 or 7. So which number is in the 40s that either ends in a 2 or a 7 and it's close to 50? We need the larger one. We're close to 50. So the answer is going to be 47. So what I want you to, we haven't got time to do lots of examples of these, but what I want you to understand is that the, depending on depending on the number you're dividing by, there's going to be a small number of options for the last digit, and that means you don't need to complete the division. You can look at the last digit and get very far with that. So if you're dividing by a number that ends in 1, 3, 7, or 9, then you know the last digit easily. So in Aliza's example, when she wanted to simplify to 1927 divided by 41, the only way you can have a number that ends, the only possibility for the answer is for it to end in 7. And there's only one possibility because we're dividing by 41 that ends in 1, 3, 7, or 9. If you're dividing by a number that ends in 2, 4, 6, or 8, two possibilities, 5 apart. And this is like the first example we did in blue. The difficult example is when your number ends in 5. This is the hardest, actually. Because it could be either all odd numbers or all even numbers. So this means if you're dividing by a number that ends in 1, 3, 7, or 9, this is the easiest case. You can be a little lazy with the calculation from the right, whichever method you like using for divisions from the right. And then for the method from the left, you know the last digit immediately. If you're dividing by a number that ends in 2, 4, 6, or 8, this is medium difficult. You just need to know whether it's the low possibility or the high possibility, because they're always 5 apart. And if you're dividing by a number that ends in 5, then you have to do more work with your favorite method starting from the right. Okay, so what else can we say about division? In the Mental Math World Cup, you'll be doing division by usually fairly small numbers, where most people will prefer to just take multiples of that number, for example, multiples of 82. If you're dividing by a number that's much larger, then this method is no longer feasible. So instead, there's an alternative method I can show you. It's called the flag method. We haven't got time today to go into a lot of detail, especially because it's quite a complex method. So what I'm going to do is I'm going to put in the main chat a link to a page, again, an article that I wrote that explained about this. So this is a method where you can divide by anything. You could divide 46,287,419 divided by pi. You could do that to 100 decimal places using this method if you really wanted to. Okay, so what have we covered so far? We've done all the methods to do with multiplication and squaring, square roots, divisions, also cube roots. And the last things I want to look at is the highest common factor, lowest common multiple, and finish with a few tricks that you can use for practicing mental maths. So as is in the chat, can you find me some factors of the number, let's do the number 88. So just show me different factors of 88. Okay, very good. Could I just could I ask Justin, can you tell us, because you had them all very quickly? Actually, it's okay. It's okay. I just copy and paste. It's easiest. Thank you. So I'm just literally copying from Justin here. These are all of the factors of 88. So all of the numbers that divide perfectly into 88. Let's try another one. What are all of the factors of, let's say, don't make it too difficult. Let's say factors of 64. No, actually, no. Change your mind. I want to do 56. Factors of 56. Factors of 56. Okay. Okay, cool. I think I'll copy Zidane's because he's got a lot of them already. So we've got 1, 2, 4, 7, 8. And then also we've got 14, 28, and 56. So these are all of the factors. What are all of the common factors of 56 and 88? Well, 1 appears in both of the lists. 2 appears in both of the lists. 4 appears in both of the lists. 7 is a factor of 56, but it's not a factor of 88, so we can't have that. 8 is a factor in both lists, and there's no more. So it's only these ones. So what have we done here? We've identified that 1 is in both lists, 2 is in both lists, 4 is in both lists, 8 is in both lists, and that's it. So what's the highest common factor? It's 8. So this is the meaning of highest common factor. And this is written often as HCF, or sometimes you see it as GCD in Mental Math World Cup. And then the way I learned maths, we called it the HCF. And you need to do these in the Mental Math World Cup. Find the highest common factor of two numbers. And so basically, if you can think of, you basically have to think of the biggest number that divides into both of them. For small numbers, you don't need much of a method. You can just think of it. It's usually fairly obvious. For larger methods, then it takes more work to find the factors, and it's useful to have a couple of shortcuts. The biggest shortcut I want to give you is the difference method. So this is the difference trick for highest common factors. So the highest common factor of x and y is also a factor of x minus y, or y minus x. You know, you just find the difference between the numbers. So in this example, (88) and 56, the difference between these two numbers is 32. Therefore, the HCF of 88 and 56 is also the HCF of 56 and 32, or 88 and 32. So you can replace one of the numbers by something simpler. In this case, what are the factors of 32? This is very easy. It's just 1, 2, 4, 16. 1, 2, 4, 8, 16, and 32. So which of those divides into 88, for example? The maximum is going to be 8. So let's try this method for a simple example. Find the HCF of the following numbers: 91 and 105. Using the difference trick. So answers in the chat, and if you want to volunteer, let me know. And I'll only accept volunteers who don't send me a million messages. If you send me the same message 50 times, then I'm not gonna. Okay, can I invite Dipanshu, please? Dipanshu.
Yeah, so the so the factors of 91 and 105, they are 3, 5, and 7. So the HCF for this would be 7.
Good, yeah, the HCF is 7. And can I also invite Imla to show us the shortcuts used here? Thank you, Dipanshu.
Okay, so basically, using the difference trick, you do 105 minus 91, which gives you 14. So the HCF of 105 and 91 will be the HCF of 91 and 14. Thank you.
Very nice, yeah. And how does that help us get to the answer? How do we find the HCF of 90? of 91 and 14?
You identify the common factors of both numbers and then pick the highest number that divides both 91 and 14.
Nice, yeah. Cool, very good. Thank you for sharing. And so my advice here is if the difference is small, like 14, it's really easy to find all of the factors. So we say, okay, does 1 divide into 91? Yeah, of course. How about 2? No. So it's not going to be 2. What else? 7? Okay, yeah, so 7 works. So the answer is going to be 14. So this difference trick is a way of turning a difficult highest common factor question into an easier one. And so when computers, in computer algorithms, they have to calculate HCF quite a lot. And there's a method called Euclid's algorithm that's done for this. And then there's inverts called like the Bazoo algorithm and all sorts of stuff that's very important in computer algorithms. And it basically works by doing this multiple times. You find a difference, you find a difference, you find a difference, you find a difference, and eventually you end up with a very small number. And the difference ends up being 0. And that means that you already found the HCF. What we're doing is just taking the difference maybe one time, and this turns the HCF into a similar question, so into a simpler question. Last theoretical topic then is the lowest common multiple. So if I find multiples of 88, the first multiple of 88 is 88. That definitely counts. Then I have 176, and then I have, maybe someone can help me with these. We have 264, 352, 440. I'll just do them actually, it's easier. 528, 616. How far do I want to go? 704. Okay. And multiples 56 is going to be 112, 168, 224, 280, and so on. So my question is, what is the lowest common multiple of 88 and 56? This means the smallest number that divides into both of them. I'll write a few more of these just to help. Yeah, exactly. So we have to go quite far. Can anyone find the lowest common multiple? Okay. Okay, nice. Can we have Usaim, please? USAIM, Usaim.
Do we
Yes,
have
sir.
Hussein?
Yes, sir.
Yeah.
The
So what?
LCM is 616.
Nice. Yeah. Very good. Thank you for that. 616. And what we notice here, we have to go quite far before we get it. We've got 504, and then 560, and eventually 616. So we have to calculate many multiples of 88 and many multiples of 56 to get to that. So what's the easiest way? What's an easier way of doing this? So this is the division trick for LCM. Or the HCF trick for lowest common multiple. And this is that the LCM of x and y is equal to x multiplied by y and then divided by the HCF of x and y. Therefore, we have a method which is step 1, find the HCF. And you know some good tricks to finding the HCF. Step 2, divide the difficult number by the HCF. Let's do an example. So the example HCF of 88 and 56, we already said that this was 7. Yeah, so divide a difficult number by the HCF, and that's, which one is the, sorry, that's 7, I mean 8. Difficult number by the HCF, maybe we can do, it doesn't matter really, let's do 88 divided by 8 is 11. Multiplied by the other number. So I should put this on the next line for the example. So the example in this case would be 56 multiplied by 11 to give us 616. So this is the usual way that I calculate the lowest common multiple, unless the answer just happens to be obvious. Let's try an example together. So let's find the LCM of 91 and 105. Remember that the HCF of 91 and 105 is equal to 7. So we can use that trick to help us here to find the lowest common multiple of these numbers. So answers in the private chat, and let me know if you want to volunteer. Nice, yeah. Let me know if you think you have the right answer. Let me know if you want to volunteer. Yeah, I've got a couple of correct answers. Okay, so can we have Arani, please? AAR, Arani.
So first, I divided 91 by 7, and that is 13.
Good, yeah.
And then I did 105 times 13, and I got 1385, I think.
Yeah, almost, yeah. 1365,
and then,
yeah.
And then that's the answer.
Good, yeah. That's the answer, yeah. Very nice, cool. Thank you, Arani. So here, we don't have to find lots of multiples of 91 or 105, because we would need to write a lot of them to do this. we would need to write 15 multiples of 91 and 13 multiples of 105, which takes too much time. There's also the prime factorization method you might have seen, and that's more commonly shown. So I'm showing you a shortcut that I use, which is faster for mental maths here, which is exactly what the method that Arani was explaining there. So this is how I recommend to think of the LCM. The HCF is usually quick to calculate, and then you can do it by a simple division and multiplication to get the answer. Okay, so that brings us to the end of the content of the different methods. I'm going to show you a couple of training tools, little practice activities that you can do. And maybe we have a couple of moments for questions, but I think we've already finished the main time for this.
Yes, we've already exceeded that time.
Yeah. Are we able to save the whiteboards? It doesn't give me an option to save the whiteboards, just in case it's relevant for
Prakhya, can we save the whiteboard? Prakhya?
Yes, Avinash.
Can we save the whiteboard?
I think Daniel can do it on his end.
It doesn't let me. There's a button that usually allows me, but it's not available on here actually.
I'll just take a screenshot if can.
Okay, yeah, that also works, yeah, for those pages. I keep it on here.
Yeah.
Okay. So I'm just going to finish with a couple of exercises. If you find it's difficult to hold all the numbers in your mind when you're doing these methods, first of all, yeah, just practice. Practice always helps, but you can also work on a little exercise you can do is to think of a number for any small number, let's say 13, and then think of another small number and then keep adding multiples of that. So if the other number I think is, let's say 27, I start with 13, I add 27, I get 40. Add 27, I get 67, and then keep adding 27. So I get 49, 121, 148, 175, 202, 229, 256, and so on. And if you practice doing that quickly, seeing the numbers in your mind, this helps you with the main step you have to do with mental maths, which is to add or subtract numbers that you can't see. Some of you are trained with the soroban, or maybe you call it the abacus. This is one way of doing it. I don't use the abacus, I don't use the soroban, I just see the numbers in my head, but I'm still processing the numbers visually. It's very valuable to practice that. Can I unshare the whiteboard now? Is everything saved?
Yeah, can you please confirm that?
Yeah, Daniel. I've taken screenshots.
Cool. Okay, thank you for that. And so I'm gonna show you a little tool that I made for especially for those of you working on a Mental Math World Cup. I'm going to show you another activity that can help you practice, which is a flashcards tool. So there's different settings here of facts that I think are important to know if you're competing in the Mental Math World Cup. So I'm going to do the times table. I'm going to do everything. So I'm going to click on this. As soon as it does it, it's going to give me some examples, and I have to type the answer as quickly as I can, and then press enter. Then when I'm ready, I press enter, and it gives me the next question. So 27. And I answer as quickly as I can. I type as fast as I can because there's a timer running in the background, and it's only going to give me 30 seconds total to answer everything. So
that's a great tool. We will make sure that we also share it with everybody on our community group.
Okay, yeah, very nice. Yeah, you're welcome to do that, and I'll drop a link to that in a chat in just a minute, so that people can maybe finish the session if they want trying this tool. I'm just going to go through a bunch of these and I'll show you when it finishes what the output is like. So at some point when a timer is up, the menu drops down. I can't write anything else, and it tells me I got this one incorrect. Actually, I misread it. I thought it was a 3 and it's not. That's my mistake. And these ones were slower than the other ones. And so your challenge is to try and get the highest score. Try to get a score of more than 20. If you're really fast, you can get a score of more than 20 on this, and that means that you have all of these facts memorized very well. So that's a little kind of gift I've made for the people who have been here in the workshop here, and also, yes, to the rest of the community can also try this.
Thank you so much, Daniel. It's really, this will be really helpful, and we'll make sure that everybody gets it. And with regards to your tip about how to start learning to do mental calculation by just adding numbers mentally, that's a fantastic tool, because, as you said, a lot of the kids over here probably have a background of abacus or a Sorobon, but what you've achieved without knowing without learning abacus or Sorobon, and doing it, even then doing it mentally, that's a great skill that you have, and that's something the kids would really value, because a lot of these kids over here do not have a mental math background.
Yeah, so the abacus is absolutely optional, but there's many people who've had success using the abacus. Both ways are working very well. And the methods you're using are pretty much the same, and they're the methods that I've shown today, and also including methods you might have seen from other resources. I know the Mental Math World Cup has provided some information with, there's a document with other methods that you can learn in a different format, which is really good. And there's some more of the advanced ones on my website, including the relevant ones that I've linked today. I think that gives us there's a couple more things I could talk forever, but I think that brings us to the end of the contents for the workshop today. Avinash?
Yes. We would have liked to cover percentages as well, but we do not have the time at this point. But you have covered it in our last webinar last year. So maybe I'll share it with the entire group so that they can have a look at that as well. I think with that, we've covered almost all that we wanted to cover in this session. And we really appreciate your time here, Daniel. And I don't know if there's anything else you would like to share with the team, and we can then wrap up our session today.
Sure, yeah. I think that's everything from me. Just a thank you for all of the people for like over 100 through most of it who were answering questions here. I have like many threads with different people on here, with people answering the questions here. So thank you very much for your contribution. It helps me run the workshop, as well as understanding which things you're finding easier and which things you're finding more difficult.
Also, as Daniel mentioned, he coaches students who are interested in mental calculations. If anybody is interested, do let us know. We can obviously share Daniel's email, and Daniel can also share his own email ID if required over here. And you can always reach out to him, and I'm sure he'll help you get your skills up to the international status.
Yeah. Thank you for reminding me of that. This is the contact. If you need to contact me, then this is a contact form that reaches me on my website, and that gets me by email.
All right, I guess so. That's all that we had for today. I would like to thank everyone who stayed till the end. There's a lot to be done now between today and the first mock test starts on the 25th of July. 25th to the 28th is the first mock test. After that, we have the first round of eliminations between the 1st to the 5th of August. So a lot to be done. I'm sure we've covered most of the important topics here. Please go back, practice. There's no substitute to practice over here. Daniel has shown you the methods, and he's given you the techniques that you can use. And just go back to use those techniques. He's got a lot of material that he's otherwise also provided. We'll share those links with you. There's also our practice worksheets that are there. Please use those, and then go to the live math competitions and leagues app. In the practice sections, there is a lot of practice, unlimited practice available over there as well. Just go and practice as much as you can. At the end of the day, you cannot, there's no shortcut to success than just to go and practice as much as you can. All right. With that said, I would like to thank everyone for having stayed back to the end. You may all now, start logging off. And if you have any questions regarding the competition, we'll be happy to answer that. Just write to us on our email, contact@livemcl.com, or drop us a WhatsApp on +91 8291 027 238. All right. With that said, thank you, everyone. You may all start logging off. Daniel, if you can just wait for everyone to just log off, we'll just end after that. Students, I think you can all log off now. Admin, can we have people? Can you remove people from? For any questions, just drop us an email, please. Have we stopped recording?
Just a moment.